Welcome back Auto-Sonic Realm. Today, we stand at a turning point in aviation history. For more than a century, flight has relied on combustion, fuel burned in engines, turbines roaring, exhaust pouring into the air. Helicopters, in particular, have remained tightly connected to fossil fuels due to their demanding power requirements. But now, a quiet revolution is taking shape. The Electric R66, a reimagined version of the iconic Robinson R66, represents a bold step toward a cleaner, quieter, and more efficient future. With its striking dual-color identity, half red and half sapphire blue, this aircraft is more than a demonstrator. It is a symbol of transition, an aircraft bridging tradition and innovation. At first glance, the Electric R66 appears familiar. Its silhouette mirrors the widely trusted R66 design, known around the world for reliability, training capability, and operational flexibility. But beneath the surface, everything has changed. The turbine engine that once powered this aircraft has been removed, replaced by a compact electric powertrain developed by magniX, one of the leading innovators in electric propulsion. The heart of this aircraft is the Heli-Storm motor, engineered specifically for rotorcraft applications. Lightweight, efficient, and capable of high RPM operation, it delivers instant torque, allowing for smoother power response, reduced vibration, and simplified mechanical layout. When technicians open the engine bay, the transformation becomes clear. Instead of complex fuel systems, exhaust ducts, and turbine components, the Electric R66 reveals an organized structure of electric hardware. Battery modules sit in modular Samson packs, engineered for high energy density, rapid cooling, and safe containment. Arrows on our visuals highlight the electric motor, the inverter, and the battery stack, giving viewers a clear understanding of how this aircraft generates power. With fewer moving parts, maintenance demands shift dramatically. No oil changes, no fuel filters, no turbine hot sections requiring overhaul. Instead, engineers now focus on battery condition, electrical connections, and thermal management systems. But this evolution comes with trade-offs. Current battery technology limits flight endurance. Where a turbine R66 can remain airborne for hours, the electric demonstrator may offer operational profiles ranging from tens of minutes to around 1 hour. This restricts long-range missions, cross-country flights, and extended operations. However, for training flights, sightseeing tours, short-range utility missions, and airport-to-heliport transport, the Electric R66 shows immediate potential. Operating costs per hour drop significantly, emissions fall to near zero at the point of use, and noise levels are dramatically reduced, an advantage for urban operations where helicopter noise has been a major concern. Moving inside, the cockpit retains the familiar layout known to Robinson pilots. The pilot seat remains positioned for clear visibility, with ergonomic controls and straightforward instrumentation. Yet a sense of transformation is present here as well. The cyclic and collective controls feel refined, responding to electric torque with smooth precision. Digital displays now dominate the instrument panel, showing real-time data on battery state of charge, power draw, motor temperature, and regenerative metrics. Pilots gain access to information never before available in turbine models, enabling them to manage energy use strategically throughout the flight. Arrows in our visual guides point to the cyclic, the collective, and the instrument cluster, the controls pilots will rely on from the first test flight forward. The transition from turbine to electric propulsion requires new training, new checklists, and new operating mindsets. Pilots must now consider energy reserves, charging infrastructure, and environmental conditions that affect battery performance. Moving through the cabin, the interior remains compact but practical. 2 forward seats provide comfortable accommodation for pilot and passenger, while the rear area offers modest space for equipment or additional passengers depending on configuration. The roof panel integrates wiring channels and avionics components, protected and streamlined for efficient routing. The gear controls and landing skids retain the robust design of the original R66, capable of handling uneven surfaces and demanding operational environments. From the rear, the Electric R66 reveals further structural adaptations. The tail drive system has been optimized to support the new electric layout, and redundant electrical pathways ensure safety in the event of component failure. Battery containment systems are engineered to isolate thermal events, reducing risk and enhancing operational safety. Emergency procedures have been updated to address unique scenarios associated with electric propulsion, including rapid power reduction and battery system management. One of the most visually striking elements of this aircraft is its dual-color paint scheme. The left side displays a bold red finish, representing the heritage of conventional aviation: powerful, loud, and fuel-driven. The right side shines in sapphire blue, symbolizing the emerging electric era: clean, quiet, and efficient. This split design does more than capture attention in a showroom or on a thumbnail. It communicates the essence of this demonstrator: a bridge between what aviation has been and what it can become. The color divide stands as a reminder that innovation does not erase history, it builds upon it. As we examine the Electric R66 further, the broader implications come into focus. If successful, this demonstrator could accelerate the adoption of electric powertrains across the helicopter market. Training schools may benefit from lower operating costs, allowing more pilots to enter the industry. Tour operators could offer quieter, more environmentally friendly flights over cities and natural landmarks. Utility operators may find value in short-range missions with reduced maintenance demands. However, challenges remain. Certification pathways for electric rotorcraft require rigorous evaluation. Authorities must ensure that battery systems meet strict safety criteria, that thermal management is reliable, and that emergency procedures provide adequate redundancy. Charging infrastructure represents another hurdle. Heliports, airports, and remote landing sites must adopt reliable charging systems to support electric operations. Without widespread infrastructure, electric helicopters remain limited in practical deployment. Yet, despite these challenges, the Electric R66 demonstrates that progress is possible. It shows that proven airframes can be adapted to electric propulsion without sacrificing core functionality. It provides a platform for engineers, pilots, and regulators to learn, test, refine, and move forward. The sound of this aircraft provides another striking difference. Instead of the familiar turbine whine, the Electric R66 produces a quieter acoustic signature. Rotor noise remains, but the absence of turbine exhaust reduces overall sound levels. This alone could reshape how communities perceive helicopter operations, reducing opposition to flight paths near populated areas. Looking ahead, the future potential becomes even more compelling. Improvements in battery energy density could double or triple flight endurance. Hybrid electric variants may emerge, combining small combustion generators with electric propulsion for extended range. Fast charging systems may enable rapid turnaround times between flights. As technology advances, the foundational work being done with the Electric R66 will serve as a reference point for industry-wide development. The symbolism of this aircraft cannot be overstated. It does not represent a complete transformation of aviation overnight. Instead, it represents a decisive step, a proof that electric rotorcraft can fly, can operate safely, and can integrate into existing aviation ecosystems. The dual-color design reinforces this message every time the aircraft lifts off, one half grounded in legacy, the other reaching toward a cleaner future. For operators, investors, and enthusiasts, the Electric R66 invites both curiosity and cautious optimism. Its demonstrator first flight, targeted for 2026, will mark a milestone that could influence design decisions across the industry. Manufacturers will watch closely, learning from the performance data, pilot feedback, and operational results. If the aircraft meets expectations, it may inspire new electric models, retrofits for existing fleets, and broader adoption of sustainable aviation technologies. As we close this examination, one truth becomes clear: aviation is entering a new era. Change will not come all at once, and challenges will continue to shape the journey. But the Electric R66 stands as a tangible example of progress. It embodies the determination of engineers, pilots, and innovators who believe that flight can become cleaner, quieter, and more efficient without abandoning the principles that made aviation possible in the first place. The red half honors the past. The blue half points to the future. Together, they represent a powerful vision, an aviation industry that evolves, adapts, and rises to meet the needs of the world. If you want more in-depth walkarounds, close-ups of the motor bay, battery modules, cockpit controls, or interior design, let us know in the comments. Like, Subscribe, and turn on notifications as we follow the Electric R66 on its journey toward its first flight in 2026 and beyond.